Welcome to our AriserTalent, my dear students. I am your maths teacher, Arpita Sharma. Students, we are going to start a very new chapter today, right? And this chapter is a chapter related to our previous chapters. That is area related to circle. Now you know this particular name, circle. You're very familiar with this word. Okay, now you are also familiar with this word area. Okay, so you are familiar with area, you are familiar with circle. Now we have to study these two terms in a particular chapter. So this chapter is quite easy for you if you have watched my previous chapters. Okay, but if you don't, just stop this video and go and visit my previous videos based on circle. Okay, then it will be quite easy, but don't bother very much, because I'm having some explanation, some basic explanation for you here in this chapter also, so that you can relate all the things. Okay, it's a quick revision, right students? Okay students, so talking about area related to circles, what I'm having is for you first to understand the basic thing. This is circle. Now what is circle? A circle is a locus. Locus is just a path, students. Locus is a kind of path, okay, of a point which moves in a plane, in such a way that its distance from a fixed point always remains the same. Now students, what is this? What this thing is gonna try to communicate with you, because it's a complicated language, but the meaning is so simple. Now, I'm saying that locus is nothing but a path. So, I'm talking about a path here. Now, if I'm here and I got something crazy in my mind, and what I did, I was having some pole here, and I tried something, okay, here, and from this point, okay, so basically this pole is here, and I am having some kind of rope. Okay, so having some kind of fixed rope, I'll be just walking like this, walking to that particular end of the circle. So how will I move? If this is the point, I'll move like this. Okay, so if I'm stretching the rope very tightly, so the particular distance will not be changed, and I'll be moving in this path. So that will be my locus. Okay, now this is the same thing here. The distance is what? Distance is constant. So this word is used here, fixed point. Fixed point, and the distance will remain always same. So a circle is a locus of a point which moves in a plane in such a way that its distance from a fixed point always remains same. Now, if you look at me from this side, that scenario will be different. But if you are looking me from something, from a roof, okay. So if you are looking me from a roof, so that will be the pole, and that will be the rope, and I'll be moving like this. This particular distance. So these all distance will be equal. This time, this rope will be like this. Okay, so this is the center here, and this path is having always a fixed distance. So this locus, this path will be known as what? This is a combined point. This is a group of a combined point that will be called we will be calling as circle. Okay, so moving to next, a circle is a locus of a point. Okay, we have done with that. So now next, that is what? Center. So the fixed point is called, that fixed point where the pole was center. and the given constant distance, that rope's length was what? The radius of that circle. So, in a common term, what I call it, if you have your protractor and will have a point and locate that particular lid of that protector this side and pencil it this side, and you will draw having this center, you will draw this. So, what will be you going to draw? A circle, right? Now, the length of the arc will be like this. This will be constant. Let's suppose this is a proper circle. Okay. So, this is the length of arc, that is your what? Radius r. You will be actually denoting it by not this. Okay. So, you will be denoting it not by this but small r. Okay. So, this is about your circle, your radius and your what? Center. Okay, students. So, note this. So, I have corrected my circle here. Okay, students. So, moving forward, perimeter of a circle. Okay, students. So, if I was talking with that particular example that I was having some crazy thing in my mind and I was like moving this like this. So, this complete, if I started this point from this point A, okay, and completed this path. So, the complete length of the path covered by me is what? The perimeter of this circle, and which is known as circumference. So, what is circumference, students? Circumference is nothing but the perimeter of the circle, which is known as circumference, right? Sorry. Perimeter and area of a circle. Now, I am having some calculations of perimeter and area of circle. So, students, it's interesting to know that the circumference is 2 pi r. Okay, this is the circumference, or pi d. Now, how 2 pi r and pi d connected? Because if you are having this circle and this be your radius r, okay, then the diameter will be this complete d is your diameter and this is your radius r. So, basically your r equals to d by 2, or you can say d equals to 2r, because the diameter is just what? Double of your radius. Now, if you are having your circumference equals to 2 pi r, okay, you can write this 2r as d, isn't it? So, your pi d will be what? Circumference again. Okay. So, students, what I am telling you is that you can have your perimeter, okay, as 2 pi r, and you can achieve your area of triangle, area of a circle with the help of the same. How? Because I am saying that if this is the circle, and this circle is consisting of infinite, if this is the center, this circle consists of infinite circles inside it. Okay. So, how it will be? I am considering some of them here, right. So, I have told you before in that particular chapter circle, but okay, I am telling you again. So, mark it. So, these are what? All circles. So, a circle inside a circle and a circle inside a circle. This is how a circle is, here. Now, what I am saying is, so what I am trying to say that is composing of infinite time circles in that. Okay. So, now what happens, students, if I am going to calculate the area, it will be the sum of all these what? Circumference. Now, if this is the radius r, this is the radius what? R. Okay. If now I break this circle from here and will convert it in a wire, I am breaking this circle from here and converting it in wire. So, what will be the perimeter? The perimeter here will be what? 2 pi r right students? And because they are infinite, so I'll be drawing infinite lines here, and first line will be somewhat smaller of the second because it's the inner circle. Okay, so there is a little negligible difference between them, but there is a difference. So okay, this will be, you know, in a decreasing order. So this line will form. So it will be like this. If you imagine this, like this is okay. Then the next one here. Okay, then the next one here. Then the next one here. Okay, then the next one here, and eventually you will be having what? Understand this figure? You will be going to have a what? A triangle or not? Right? A triangle with the height what? From these infinite times, you will be having a triangle. This triangle whose height is what? This, and this is what? R. So this triangle with R height, if you will be calculating the area of a triangle, that will be half by base by height. Now the base is 2 pi r and the height is r. So this 2 will cancel out and that will be pi r square. Isn't it students? So the area will be like this, note it. Okay. This is about the area in the terms of radius. This is the area in the term of radius. So what about in term of area of circle? I've told you this is pi r square. I've told you the process how it is pi r square. Now that is equals to what? Pi r equals to d by 2 square. Okay, so that will be pi d square by 4. Isn't it students? So I can write it like pi by 4 d square. Okay, so here I am having this area equals to pi r square or pi d square by 4. Now don't get confused that I am having this formula or this formula. These two formulas are quite easy to relate. Okay, now the area of semicircle. Area of semicircle. What is semicircle? Semicircle is just half. If this is your circle, okay, and the semicircle will be, you will be having a diameter. So this side will be semicircle. If you cut this circle from here, this will be the semicircle, this will be the semicircle. Now this is this complete having the area of pi r square. Now what is the area of this semicircle? It's so obvious, it will be just half of that. So pi r square by 2, isn't it? So I am having this area of semicircle pi r square by 2. Area pi r square or pi d square by 4. Okay, area of semicircle pi r square by 2. Area of a quadrant of a circle pi r square by 4. Now what is quadrant? 1 by 4th. 1 by 4th. Now simply you can say that what is 1 by 4th of a area? 1 by 4 of pi r square. That will be what? Pi r square by 4. So there is any kind of that much rocket science involved in that. You can easily find these all things, right students? Okay, so now we are done here with these kind of things. Now we'll move forward. So area enclosed by two concentric circle. Okay, so I'm having two circles, students. Concentric circle. Okay, so now what is concentric circle? Two circles whose center is same, but radius is different. Because if the radius will be same, the circle will be only one. Okay, it will be overlapped. So the radius is different, but the center is same. So concentric circle. Okay, this is what, this is my center I will be naming it like O. Okay. Now what I am having? I am having this radius. I am having this radius which is equals to, let's suppose R, small r I am saying. Now I am having another circle with the same center. Okay, my dear students, and this is what I call R. So, what will be this area? This is the area enclosed by the circles. Okay, I will draw it well. So, it is a nice diagram. Okay, students. Now, you know that what area I am talking about. I am talking about this area enclosed by two concentric circles. So, these are two concentric circles of radius R and capital R, and I am talking about this area. So, what is the area enclosed by two concentric circles? Now, student, imagine this, or I can just tell you. Okay, students, so you can visualize it like this, that you are having this circle. Okay, students, you are having this bigger circle and you are having this small circle, right? Now, if this circle and this circle, okay, these two circles are there. Now, I am just mentioning you. Okay, so this is first circle, this is second circle. Now, what is the area enclosed by these two circles? This is the first circumference and this is the second circumference. So, when I am talking about the area enclosed by two circles, this is this one, this shaded portion, or you can, if you cut this portion, it will be like this. It will be like this. Okay, students. So, I am talking about this area only. Okay. So, what will be this area? I just, for this circle, what I have done? I took a circle of this, okay, and I just removed this circle from there. So, understand, the area of this circle minus area of this circle, the small circle will be equals to what? The area enclosed by two circles. So, I am going to have this concept here, this you can say that like a simple concept here, that area enclosed by two circle which concentric equals to what? Area of larger circle minus area of smaller circle. Now, if you talk about the area of larger circle, so area of larger circle is what? The radius is r here, so it is pi r square, and this is minus pi small r square. So, that will be pi r square minus r square. Now, if I will expand it like a square minus b square, you can also write it as pi, sorry, it is r, capital R minus r, I should rewrite it, okay. So, it will be pi r minus r and r plus r. So, any of that particular format I can use to have this area enclosed by the circle, understand it, okay. So, let us see this. This is a proper, right, this is a proper diagram of actually concentric circle. So, here I am having this center O, and this is center of these two radius. This is R, small, capital R for the larger circle and the small r for smaller circle. And now I am having this pi r square minus pi r square, the area of this enclosed the enclosed area from these two circles, okay, equals to pi r square minus r square equals to pi r plus r minus r. The first r is capital, second r is smaller, right, okay. So, students, this is for the area thing by two concentric circle. Now, it's a useful result. Some useful result. Why these are so useful? Useful means we are using them in something, and the most useful things are which are we going to use in our questions. So we are going to use these direct results in our questions, right students? So these are important. So just listen to them carefully. If two circles touch internally, now if two circles touch internally, that means this is one circle having some radius, and this is the second circle. This is the second circle having center here. Okay students, now what will happen? This is having some radius r and this is having some radius capital R. Okay, now students, the difference, okay, the difference between R and R will be actually the difference in the centers of this. Okay, if this is having, this is bigger, so I will call it O and I will call it O dash. So, O minus O dash will be equals to what? R minus R. Radius of larger circle minus radius of smaller circle. Okay, so if two circles touch internally, then the distance between their centers is equal to the difference between their radii or their radius. Okay, so this is the radius of this and this is the radius of this. So difference between these two radius will be ultimately give you the distance between center, because imagine now if this is concentric with this and we are having some centers here. So now this point on which they are touching, if this is these two centers are internally touch each other, so that will be a point. Okay, from this point we will mark a radius to that and a mark a radius to this. This is R and this is small r. So this will be what? Simply R minus R. Okay. Now what happens if they touches outside? Outside. Okay, this is R and this is some radius R. So now the distance between their center will be what? You can easily say if they are touching externally, the difference between their centers will be nothing but R plus R. It's so simple, isn't it? So it's giving if two circles touch externally when the distance between their centers is equal to the sum of their radii. Okay, distance moved by a rotating wheel. Distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. Okay, now what is wheel? You have your bicycle, right? And you have your bikes, right? So you're having tire in that is wheel obviously. So let's suppose this is your tire, this is the tire of your bike. Okay, here, right? Now the complete circumference of this is this. Now if I start from this point and you will move your bike forward, then this will rotate like this and it will rotate and it will change its position and will be having some distance covered here, and when this point again, this A point is again here, okay, the same point is again here. So what will be distance? Distance will be the complete revolution, and the revolution is what? 2 pi r. So basically the one revolution distance covered by wheel is equals to what? 2 pi r, the circumference of that wheel or that tire. Okay, so we are going to use this theory in questions. Okay, so distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. The number of revolution completed by a rotating wheel in 1 minute. Okay, rubbing that all, you're having all this written in this slide. So note that, okay students, in your notebooks, it's important, right students. Now distance move, okay, the number of revolution completed by a rotating wheel, that is number of revolution, that will be what? Distance, okay, and the circumference. And distance in what? Distance in 1 minute students, distance in 1 minute, distance in 1 minute divided by circumference. That will be what? Your wheel. Your number of revolutions completed by rotating wheel in 1 minute. Okay. So, let's move forward. We are having this question here which is saying us to find the area of a circle whose circumference is 22 centimeters. So, what is the question saying is, we have some given parameters here and I am going to write given parameters in this side. So, we have provided with area of circle and whose circumference. Circumference equals to 22 centimeter. What this implies that, what is circumference formula? That is 2 pi r. Remember it. 2 pi r equals to what? 22 centimeter. This is given. Now, to find, you can write it equation 1. To find, what we have to find? Area of circle. Now, the solution at this side, the solution part, from equation 1 I can write, from equation 1 student, can I write 2 pi r equals to 22. What does that mean? Implies that pi r equals to what? 11, isn't it? Because this, now value of pi, I am talking about the value of pi, okay, just I am not solving it here. You will take always value of pi equals to 22 by 7, always, unless otherwise it is specified. If you are given a particular value of pi in question, you will use that, but if you are not provided with that, you will be going to use 22 by 7 only. Okay, so what I can write? 2 multiplied by 22 by 7 multiplied by r equals to 22. Now, this will cancel out. So, what will be remaining here? R equals to the 7 here and this 2 here, 7 by 2. Now, when you solve it, you will be having 3.5 of what? 3.5 of what? Centimeters. This is your radius. Now, by formula, which formula? I have asked to find the area. Area of circle, which is what? I have told you, equals to pi r square. Okay, so area of circle is pi r square. So, what I can write? Equals to pi multiplied by 3.5 square, or I can write 22 by 7 multiplied by 3.5 and 3.5. Okay, students. Or what else I can say? 7 by 2, 7 by 2, I can write this only, because 3.5 is nothing but 7 by 2. Okay. Right. So, this 7 will cancel out by this 7 and this 2 by this 11. So, what you have left with? The 7 and this 11, that is 77, and this 2, that will be coming here. So, that will be 3, then 1, 8 times 0.5, right? Right. Okay, so this will be what? Your area, centimeter square. Don't forget to use the units here. The area will be in centimeter square. You can also say that 3.5 what? Centimeter was your radius. So, 3.5 centimeter multiplied by 3.5 centimeter. So, whatever the digit will multiply, the centimeter will be multiplying by centimeter. That will give you square, centimeter square. Okay. So, 38.5 centimeter square will be your answer here. Okay. So, this is your answer, students. So, note this and I am going to rub that one, right. So, students, this is one. This is the very first example of our exercise. Now, we are not going to stop here, but for now, I am going to stop there and we will continue the remaining exercise and the remaining quality questions in my next lecture. So, watch it there. Okay. Till then, take care, students. Bye-bye.